Hi, everyone. What we're going to be talking about today is finding the radian measure of an angle and also coming from a radian measure of an angle and converting it back into degrees. So basically, there's more than one way to measure an angle. Just like if we were going to measure a distance, we could measure in centimeters or we could measure in inches. There are different methods, um, different units of measurement. We can also measure angles in radians. So, what you need to know is that a radian is the measure of the central angle of a circle that intercepts the arc, equal in length to the radius of the circle. What does that mean? Well, first of all, we're going to talk about circumference of a circle. And I believe that you all remember circumference of a circle is 2 pi r. Okay, so when we talk about the circles that we've been working with, okay, let's draw our quadrantals in here. Okay, let's remember that this is 0 degrees, this is 90 degrees, 180 is over here, and 270 is over here. And of course, we know this circles back to 360 degrees. So let's think about this. One revolution in degrees is 360 degrees. Okay, so that's good. We already knew that. It's old news, right? So if we know that this is a unit circle, now what does that mean? A unit circle is a circle whose radius is 1. Okay, so all the radii are 1. Then what we know is that the circumference would be 2 times pi times 1. So the circumference would be 2 pi. Now, these two values, they might be measuring around the circle differently, but they both measure 1 revolution around the circle. And like I said, we're dealing with a unit circle, so it has a radius of 1. So here's what we need to know. 2 pi is essentially equal to 360 degrees. So divide, we get pi is equal to 180 degrees. So what does that look like? That means that here is equal to pi radians, another way to measure. And the bottom half of the circle, obviously, is also equal to pi radians. So pi and pi all the way around, a full rotation is equal to 2 pi radians. So one of the things we're going to do is we're going to have you converting from from radians to degrees and degrees to radians. So let me see if I can remember how to move this. There we go. Now I have a mouse. There we go. Sorry about that. So to convert degrees to radians, we multiply degrees by pi over 180. Now remember, pi is equal to 180, right? I have it actually right at the top of the screen here. Pi is equal to 180. So in a sense, we're multiplying by 1. And then to convert from radians to degrees, we multiply by 180 over pi. Again, pi and 180 are equal to each other. So we're not changing the value of the rotation of the angle. We're just changing how we're measuring it. So I'm going to enlarge this a little bit. Let's do a couple of problems together. So we have 60 degrees, and in order to convert that, we're going to multiply by pi over 180. Okay, hopefully you can see pretty easily that we can reduce this. And what we know now is that 60 degrees is equal to pi over 3 radians. I know that looks weird. You're going to get used to it. Okay, let's go ahead and do the next one. 270 degrees. Now, let's just think of the 270 degree angle. It's 3/4 of the way around. So it's got to be more than pi because pi was halfway around. So we will multiply by pi over 180. We'll do some reducing. These are both divisible by 90. So this is 3 and this is 2. So that tells us that 270 degrees is equal to 3 pi over 2 radians. So I'm going to pause this video. You're going to pause this video. Go do the next few problems and let's see how you do. All you're doing is multiplying by pi over 180. Okay, so let's take a look at these answers. Hopefully you did okay. And it will also be helpful to think about what these angles look like. So you're going to have to eventually memorize these radian measures. So again, if you can think of like the 90 degrees is to here. Well, if this is pi, well, this is half of pi, right? This is pi over 2. So that's definitely going to be helpful. Okay, so let's go ahead and let's convert now the other way. So if I give you the radian measure and I ask you to convert to degrees, you're essentially going to multiply by the reciprocal of what we just did. So we will be multiplying by 180 over pi. And of course, the pi's cancel out. 180 divided by 4 is 45 degrees. Same thing here. We're going to multiply by 180 over pi. Very quickly, you'll see the pi's cancel out. 3 and 180. We get a nice easy thing to reduce there. And we have negative 4 times 60, which is negative 240 degrees. Okay, so again, think about, is this value bigger than a half circle, smaller than a half circle? Where approximately does this lie? And go ahead and convert these. Think about that while you're doing them though. Pause this video. Okay, let's take a look at these answers. Hopefully you did okay. I didn't cross everything out and do the reducing, but I hope that you did because it'll definitely make the calculations easier, especially if you're not going to have a calculator. Okay, so let's move on to the next page. So, you know that when we were dealing with angles and degrees, we had coterminal angles. Well, we also have coterminal angles when we're dealing with angles in radians. So, all we have to do to find angles that are coterminal in radian measure is to add and subtract multiples of 2 pi. When we were working in degrees, we were adding and subtracting multiples of 360. Well, here we add and subtract multiples of 2 pi, which again, 2 pi is a full rotation. So that's why that works. So I started you off here with something you know, which is working with degrees. So we have 400 degrees. Obviously, that's more than a full rotation. So we will take 360 degrees away. And what that tells us is a 40-degree angle is coterminal with a 400-degree angle. Let me just let you look at this, okay? Here's what 400 degrees would look like. Something like this. And what we're essentially doing is we're taking all of this away, that 360-degree rotation. With negative 135, I'm going to sketch this out. Negative 135 goes this way. So what we're going to have to do, because it's negative, we will have to add 360 degrees to it, which will bring us here. Okay, so plus 360 degrees. And that gives us a 225-degree angle, which is coterminal with a negative 135-degree angle. All right, so let's take a look at this next one. And 22 pi over 3, what is that? We actually want to convert that into a mixed number. So we know 3 goes into 22 7 times with 1 left over. So 7 1/3 pi. So if you think about it, if we take away 2 pi, that's still not going to get us to an angle that's coterminal. And remember, we're looking for an angle that's coterminal that's going to be between 0 and 2 pi. Okay? In other words, one full rotation in the positive direction. So if we take away 4 pi, that's not going to be enough. But if we take away 6 pi, what that leaves us with is 1 1/3 pi. Now, to be honest, we don't usually leave our answers for radians in terms of mixed numbers. So we will convert this into an improper fraction, and that would be 4 pi over 3 radians. Okay, now just so you know, what does this look like? I'm going to do it right over here. Here's 1 pi. So 1 1/3 pi would be right about here. Okay, because remember, 1 pi is a semicircle. It's halfway, it's 180 degrees. And 1/3 pi would bring us 1/3 of the way around the other half circle. I'm going to do one more with you, and then I'm going to stop. You're going to stop the video and try to do the next 4. So again, same deal. We're going to convert this to a mixed number. So it's going to be negative. 6 goes into 17 twice with 5 left over. Okay, so let's think about that. If we add 2 pi, we're still going to have negative 5/6 pi. So what we're actually going to do is we will be adding 4 pi. When we add 4 pi, what we wind up with is, I'm not sure how you would do this, if you would change things around, if you would make this 3 6 over 6 pi, that might work for you. Think of this as 3 6 over 6 pi. 6 over 6 minus 5 over 6 gives us 1 over 6. I just broke up one of the pi's. And then 3 minus 2 is 1. Okay, that might have been one way that you would do that. And of course, we're not going to leave it as a mixed number. We're going to make it improper. So the answer would be 7 pi over 6 radians. Okay, so again, let's look at what that looks like. I'm going to draw it down here just so you can see it. So we started off with negative 17 pi over 6, which when we actually did the math, we found it was negative 2 5/6 pi. So here's negative 2 pi, a full rotation in the negative direction. And then we need 5 over 6 pi, which is going to bring us not quite another pi. We're finding out that 1 1/6, or 7 pi over 6, is equal to that. Well, let's think about it. Here's 1 pi, and here's 1/6 pi. So it brings us right there. So you are going to go ahead and do the next 3 problems, okay? Or I'm sorry, the next 4 problems, and then check back in with me. So stop this video. Okay, so take a look at these answers. I want you to notice something. The way we express our answers, I wouldn't write like 2/3 times pi radians. We kind of make it one fraction of 2 pi over 3 radians. We wouldn't write 1/2 pi. We would write pi over 2 radians. Same thing here. We wouldn't write 1/4 times pi radians. It's pi over 4 radians. So just a formatting thing there for you. Okay. So this all starts to feed into the unit circle. It is time, people. This is a big deal. This you are going to need to memorize and memorize the degrees and the radians and how they relate. So I'm going to zoom in a little bit. I'm going to bring that up. We are going to go around this unit circle, each of these unit circles, and we're going to put the equivalent of the degrees. We're going to put the equivalent radian measure. So I'll start you off. First of all, what you need to know is that a 30-degree angle If you did 30 times pi over 180, which we already did, we get pi over 6 radians. I'm not going to write radians every time. Okay. So every 30-degree slice is equal to pi over 6 radians. Memorize that, because a 60-degree slice is just 2 of those. So 2 pi over 6 radians, which we reduce to be pi over 3. Memorize that every 60-degree slice is equal to pi over 3. 90 degrees would be 3 of these. So 3 pi over 6, which is pi over 2 radians. Notice 1 pi over 6, 2 pi over 6, 3 pi over 6. Now we would have 120 degrees would be 4 pi over 6, which we will reduce, 4 pi over 6, we will reduce to be 2 pi over 3 radians. 1, 2, 3, 4, 5 pi over 6. And then, of course, 180 is 6 pi over 6, which is just pi radians. Now we continue to add 30-degree slices. So let's think of this as 6 pi over 6, which makes 210 degrees, 7 pi over 6. Oops. 240 would be 8 pi over 6, but that reduces to be 4 pi over 3. So we were at 8 pi over 6. Now we have 9 pi over 6. Well, 9 over 6 reduces to 3 pi over 2. Think about this. This is 1.5 pi. Okay, 1.5 pi, or 9 pi over 6. 300 degrees would be 10 pi over 6, but that reduces to be 5 pi over 3. A 330-degree rotation would be 11 pi over 6. And a 360-degree rotation is 2 pi. And those are all in radians. I know I didn't write them. You probably didn't either. Okay, but just know those are the radian measures that go along with those angles. Those 30-degree angles, we've been talking about 30, 60, 90s for a while now. You know they're coming back. These are values you need to memorize. These are things you want to know, boom, 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 where you don't even have to think about it. Okay, so the same goes for the circle on the right. Notice that these are all 45-degree slices. So if you think about it, if 180 degrees is pi, and it's been broken into 4 slices that are equally sized, 45 degrees would be pi over 4. 90 would be 2 pi over 4 or pi over 2. I mean, it should make sense that if 90 degrees is pi over 2 here, that it would be pi over 2 here. Okay, so 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, which would just be pi. Same thing as here, right? Next would be 5 pi over 4. 270 would be 6 pi over 4, but you know we're going to reduce that to be 3 pi over 2. Again, the same as what we had over here, 3 pi over 2. This is the 7th 45-degree slice, so it's 7 pi over 4 radians. And then, of course, 8 pi over 4 would be 2 pi radians. Again, the same here and the same here. So there's some overlap to these, okay? The quadrantal angles are the same, okay? So those are good like anchor numbers to know. And I'm telling you right now, you need to memorize these values. So maybe you can make some note cards, maybe color code them like I did here. All the 45-degree angles, make them in one color. All of the 30-degree multiples, make them in another color. Okay, memorize, memorize, memorize. Have a wonderful day, everybody.